Okay, do you want the questions or do you want the bonus slides? I don't have any bonus slides. I do have a few things that I could show and tell, but they're not slides. So if you guys don't come up with good questions, I will inflict some of my recent and some of my not so recent programming on you. Just things I play with, my hobbies, what I use Perl for. But did anybody come in with a burning question that they wanted?
How are you this morning?
How am I this morning? I am still jet lagged. This is going to be quite hilarious. Yeah, maybe. I better drink some more sucrose brown water here. In more general terms, I have discovered over the last decade or two that I am mildly bipolar, so I have my good months and I have my bad months. This last month was a little low. I tend to now my definition of low looks like some other people's high, I think, but. I did a lot of things during the last month, but mostly puttering around and fooling with hardware, repairing my TiVo 3 or 4 times. I just can't stand the idea of having something with a lifetime subscription that is dying. So I resoldered the power supply several times on it, and that didn't work out so well. So by the time I got the 3rd power supply in it, it's now working again. I've been doing other little hardware things. I've played electrician at church. I've set up stage lighting. I played drums in the band. I do a lot of stuff when I'm depressed. But what I try to avoid doing when I'm depressed is actually doing anything strategic. I've been doing some hacking inside the Perl 6 core over this year. Most of it has been sort of prep work for optimizations we want to do later. But this last month I've kind of stayed away from it because I know if I made any big decisions this last month, they probably would have to be undone. Question in back? Well, I think it's a great thing that he's doing. We don't happen to agree on bracketing styles, but that's no secret. But the more the merrier. I sort of love the way he's always asking questions on Stack Overflow and eliciting answers from the community. That's his way of interacting. He's not really an IRC person, and so he stays away from the IRC. But he's obviously feels at home at Stack Overflow, and that's also a good way to do it. There's many ways of getting information flow going, and we don't have to stick with one of them. I mean, I first learned to use IRC because of the Perl 6 effort when they started developing pugs. When Audrey started developing pugs, she got me onto IRC, and I've never looked back since. But we used to do everything by email. The first few months of the Perl 6 effort, it was all mailing lists. It's kind of instructive to go back and read those mailing lists sometimes, and it's like everyone's struggling around to try to figure out what we should do for Perl 6, and I still find it entertaining to go back sometimes and actually look at the RFCs, which I have them in some window here. Can you tell I have too many windows? Well, let's go over here. Oh, I remember where it was. Of course somebody else is doing it. That's the one problem with having too many windows here, is I misplace things. There it is. I knew I had it open. I wish there was some easy way of just stealing it. There probably is. Yeah, we had the original RFCs here, and these were all worked out on email. This is something that I did a few years back, where I just went through all the original RFCs, and I said to myself, well, how did we actually work out with the design of Perl 6 over time? And so this is my responses to all 365 RFCs. No, that's how many days in a year. 361. Yeah, that's how many. And we came up with all these various principles, design principles, which all fight against each other, and that was all fun. I don't know how many of you noticed when at this point, or just a little fun thing here. The color coding and the letter coding, the meanings are actually the color letter. So G is green, C is cyan, Y is yellow, R for rejection. Yeah, it made a lot of sense at the time. But we actually did an awfully good subset of this. It's still a work in progress, but we're pretty happy with where we got so far. Anyway, so yeah, mailing lists, communication. Can you tell I'm wandering this morning?
We should talk about
One implement in yellow. Yeah, well, plan to know more someday. That is turned out to be one of the more important of our principles, because we had a lot of ideas early on, and many of these the RFCs suggested ideas, suggested implementations. Most of the implementations suggested were bogus, in the sense that they all had tunnel vision, and they they were just going to fix the one thing and leave everything else the same, and they didn't have a cohesive redesign. But some of them, it was kind of obvious what direction to go, or at least with some thinking how to unify the underlying ideas. But there were some things we knew we didn't know enough about, and one of those was threading. We knew that all the current thread models that we had sucked, and we knew that multi-core and many-core processors are coming down the pike. So we put as much into the design about parallelism and concurrency as we could, but we also refrained from designing some of the concurrency primitives until the right person came along to actually to think about that. And that turned out to be Jonathan, who figured out which concurrency primitives would actually be composable, which turns out to be the most important aspect. The way most threading models break down is that they aren't composable. If you make threads of threads, it doesn't work. So things like channels and promises and functional reactive programming, these scale much better. So and can be composed. So yeah, that's one of the more important principles that we came up with. Picking the right defaults. This is always in all your programming. You just should be thinking about that all the time. I have some recent programming I'll demo where I had the wrong defaults, and I'll just refactor them to be the other way around. Yeah, there aren't enough sigils. Don't overuse them. Yeah, don't just do the first thing that occurs to you. That's PHP. self-clocking code, some of these things are quite subtle, but many of them are ideas that were sort of nascent in Perls 1 through 5, and we recognized, this is what the essence of Perl is, and that is the kind of essence we want to carry forward into Perl 6, even though we're not going to, keep strict syntactic compatibility. So this was it took a long time, but it was a very useful, in retrospect, a useful process in that it helped us define what we actually like about Perl and how we could carry that into the future. Avoid lists of exceptions, like in standard in, standard out. Those are exceptions in Perl 5. They're global everywhere. And so we did it differently in Perl 6. Well, I could spend all day on these, but
Everybody's complaining about Perl 6 and performance.
yeah, the question is, and I haven't been repeating the previous questions correctly. Remind me. The question is, can I speak to the subject of Perl 6 performance? We intentionally followed the principle, make it run, or make it work right, and then make it work fast. And so there was very little optimization work before we released the Christmas version of Perl 6 a year and a half ago. But the design was designed such that it could be optimized with that, proverbial sufficiently smart compiler. So we're starting to reap some of the benefits of that, having nailed down the actual definition of the language syntactically and semantically for the most part. Then we actually had a stable platform that we could actually do optimizations and test them heavily and a benchmark and see what helps and what doesn't. So we've made a great deal of progress on that. It's still not quite as fast as Perl 5 most of the time. And there's still some places where it's considerably slower, but it's getting better all the time. We're still, we're just now getting a new JIT that has been in design for a year and a half, when we start using that new JIT, we should be able to produce much, much better JITted code. So, we're kind of following the same path that Java did because, Java started out really, really slow. And nowadays, it's at least for large, long-running processes, it is quite speedy. But, we mostly, the design was optimizable, not optimized. And now we've been doing the optimization. And, my own personal, different people optimize different parts of it. We got Bart working on the JIT, Jonathan and many others working on the more VM level, which is down at the C, the VM level. Liz is doing a lot of optimization at the NQP level with lists and how they are generated. And my own bailiwick on the optimization front is more in the compiler, the parser. So when I mentioned earlier I was getting ready to do some optimizations, we know some places in the parser that are slower than they should be. For instance, one of the things about Perl 6 is that it writes a lexer for you. You never write your own lexer. So as you add grammar rules, it says, oh, you're deriving a new grammar, write a new lexer. And as it calls down from rule to rule to do matching, it's running NFAs, non-deterministic finite state automaton. in parallel to do the longest token matching. Well, one of the things that it does right now is at the top level, so you're going to parse a statement. And statement says, oh, well, that could be a keyword or it could be a term because you're starting the expression. So it runs this big NFA that has all the sub-NFAs inside of it. And it says, oh, it came up with some sort of a term. So we're going to go drop down to the term parser. So the term parser says, oh, well, we need to figure out what kind of a term. So it runs its own NFA, despite the fact that we already determined exactly that it was, like an integer or something. It still has to run its NFA and determine, oh, this is some kind of a number. So it drops down to number, and number says, okay, what kind of a number is this? Let's run an NFA. So if you actually add up, if you actually go in and mark how many times the various lexers re-look at various characters in your Perl 6 program, it averages 5 or 6 times on every character, which is obviously deeply suboptimal, and we know how to fix it. The original prototype of a parser, which was called standard STD, no pun intended. Well, maybe it was. Had the system which we called fates, where when it ran the NFA at the top, it not only determined, oh, I am going to be a term, but it also figured out, and when I call term, it's going to be a number, and when I call number, it's going to be an integer. And it would actually pass down and say, you don't even have to match anymore, just pretend like you matched. And so that with that mechanism, you never rerun your lexers at a lower spot. So that's one of the big optimizations I'm planning to do shortly. But I had to do some prep work to get that ready, and then I got depressed.
Are you hearing much about anyone using
Well, there are people who've been using it in their business. So far, most of it is hobbyist, and it's a great hobbyist language so far. There are people who have been seriously starting to use it in their businesses. I've been using it in anger for 7 or 8 years now, and I was actually planning to show and tell some of my ancient Perl 6 code that I've been using for years. Just kind of show how long it's been usable, and more just to show some of the things I'm interested in. One of my oldest programs is my wife runs likes to run a quiz team at our church. Our teens in our denomination do Bible quizzing, and it's kind of like College Bowl, and so I've been helping out with the scorekeeping for years and years and years, and it actually started out that I just had a file that looked kind of like this. Now I've anonymized the names here, as you can tell, but this is actually some real quizzes. This is actually a little kind of going off the edge there, but so you have 2 teams there, Team 1, Team 2. You can probably tell the bottom one is actually San Jose. And you see lots of zeros and 20s and a -0, which indicates a missed bonus. That's that sort of thing. And they're running team score on the bottom because there are individual points and there are team points. You can have team pluses and minuses. So originally, I actually edited this by hand with a set of Vim macros that would actually just go from number to number, and I could say, okay, increment this, decrement that, and I'd read the score sheets. They'd all come in by paper, and then you know, I got kind of tired of that and was a little bit error prone. So I said, well, this is something that I can probably automate. But before that, I actually had taken the program that actually processes this. The original Perl 5 program looks like this, and basically it just loops over all these scores that you saw in that other file. And you know, when we pass a round marker, we increment the round. We pass a quiz marker, we increment the quiz, and it makes sure that every game has two teams. And then after we've just loaded everything in, it basically comes down here and ignore the cumulative stuff. But it goes through the teams and it goes through the individuals, and it does a big sort with this huge sort that comes out with scores. Lately, I've got the Perl 6 version, which essentially is just translated Perl 5, so it's not entirely idiomatic in Perl 6, but I do some things like say when we leave this block, then close this file. So that's people keep asking for Python's width. That's basically how we do width in Perl 6. If you go down and look at the equivalent sort routines, wherever they are here, they're smaller, so it's harder to see them. Oh yeah, see basically Perl 6 will do the Schwartzian transform for you. So you just give it singularity things, and it will automatically do the right thing. Anyway, that's when you run that program on those score files, then you get. Oh boy, let's shrink this a little. Okay, that looks a little better. It gives you the individual scores down the left, and you know it's ordered on points, and then errors, and then memory verses, and also has points per quiz. And it also ranks the teams. You notice your teams are ranked by win-loss, and then if two teams have the same win-loss ratio, they're ranked by head-to-head scores, and it actually figures out, you know, whether they're cycles or not. So you can tell that. If there are cycles, then it goes to points as a tiebreaker, and then errors, and it's the same as individuals. So, and this is all for setting up, you know, a round robin. This is the round robin part of it, which is for, you know, setting up brackets, and it's kind of a little bit important because these teens are actually quizzing for scholarships and, you know, real benefits. So you know, it's kind of important that we get the scoring right. So I got tired of using the Vim macros. So if you I wrote a program that actually goes out and is an editor for these things. And so it looks kind of like this. This is the same scores that you saw before, but they're a little more accessible here. So we can go anywhere in here, and it does a lot of double checking. If you put a duplicate score somewhere, it says, yeah, that doesn't make sense. And you can type in one of these score sheets in a minute or so, and so you can actually run quite a few rounds of quizzing, even with a paper system. But the program itself is over here. So it's just doing ANSI graphics. It's not even using curses or anything. This was, you gotta understand, this is written when Perl 6 was just starting to work, you know. Back when the slogan was, it's a good thing there's more than one way to do it, because most of them don't work. So you see things like you know, hardwired ANSI sequences here. Find the screen size here at the end. Well, shell out, and we didn't even have a way to pull in a pipe at that point, so dump it to a file, then read the file. And obviously it's Unix or POSIX specific. There's all these, well, this is the input and output routines. The single character I/O is done by repeatedly appending to the current buffer until we can successfully decode the buffer as a character, in case there are you know, multi-byte Unicode characters in there, which there are nowadays. So, and you know, the basic, of course, it has a help screen, and this is the main switch where we're processing the various keyboard things. This is actually one of the first object-oriented programs I wrote in Perl 6. So it has a class quiz and a class seat in a quiz, and a class for teams. And it has some methods, though largely it's a lot of this is just using these as fancy structs. So that's one of my ancient programs. Another one that I like to show off sometimes is my Chinese characters. I've been making this database where you can go in and say, show me all the CJK characters that have a tree on the left and water somewhere. And the ones with 4 digits are in the base plane. As you can see, some of the characters, they're up in the extension plane, and you never see these even in China. I mean, except maybe in a name or in an ancient manuscript. So even the Chinese don't know what half of these symbols mean. But I like to be able to describe them, so I came up with this database where you could do that. And it's basically two really grody programs. The first one is so grody that I haven't even bothered to rewrite it from Perl 5. It wouldn't be fast enough in Perl 6 anyway. As it is, it takes 70 seconds to go through this this database of all the characters. So the real characters start up 4E. Yeah, 4E with 1. And it gets more complicated from there. The hex code, number of strokes in the character, a definition of what H bar is, horizontal bar, and the semantic meaning of it. So I can do things by shapes or by semantic meaning. There's just a lot of interesting stuff here. But what I have to do, this program, it goes down in here and splits into a file that looks like this. So if I go to that same well, let's go to something like shell. The original, up to the bracket here, is the original entry. This is the expansion of it all the way down in here. So it's like I on top means you have two vertical bars on top and 4 horizontal bars. There's semantically an 8 on the bottom of it and an I on the top, and there's lines and ones and H bars. And that's one of the simpler ones. I mean, and this one has shell on the bottom and a pointer on the top, and that expands even further. So the longest one of these is like 6,000 character line. So that would be a lot of stuff to search through. So what it actually does, it goes down into for each of the main characters, it creates a bitmap down in this directory. And so the reason this can be so fast over on the left is because the other program is taking these bitmaps and anding them together and ignoring all the lines from this file that are not set in that bitmap. So, yeah. Now, the new one I have written in P6, and so you can kind of tell the performance. If I say time, rad, tree on the left, water on the right, it says about 2/10 of a second, about 1/5 of a second. If I do the same thing in Perl 6, it's still about 2 seconds and a bit. So there's obviously some room for improvement yet. Okay. Now the one I really wanted to show you, unless you have more questions, feel free to interrupt with questions if you.
So last year,
Yeah. A lot of work has gone into the async stuff this past half year. It's a lot more robust, and that's one of the things that's Jonathan's bailiwick, and he's been doing a pretty good job with it.
That list you showed us with the posted somewhere?
Yeah, I think I if not, I can. Send me email later. I can remind me.
They want to see more of that.
Yeah, I do. But I want to talk about tournaments.
I know.
Okay. So because, when I'm doing the scorekeeping for these tournaments, I'm bored part of the time. We have tournaments and some schedules that we have pre-cooked here. So sometimes we have multiple pools, and so that's just an 8-team tournament. 7-team. Some of these have like 2 pools, so they'll have. If I go with here is a tournament with two pools of 6 teams each, and we typically put a 10 on the front of the other pool. And it's in 6 rooms, so there's no compression of it. And I thought, I know there's stuff online for this, but I thought I'm bored. I'm just going to write the program to do it. So I started off with this program, which I called Round Robin, and it was just kind of hacked together. And so if I say Round Robin 8, whoops, that's going to take a while. Round 8. It gives you a very randomized. It just defaults to mixing it up in every order, with the constraint that you can't be in 2 places at once. So Yeah, that was fine as far as it went, but you notice we have multiple pools, and I wasn't really happy with this particular program because I mixed a bunch of stuff together. It's all in a main subroutine here, and the actual algorithm is that does the round robin is obscured because I'm also doing this randomizing stuff in the middle, and so there's a bug in the highlighter there. So I said, well, okay, how would I go about refactoring this? So first thing I said was, let's try some things here. Let's spread these out so we can actually see what we're doing. And let's split this main thing into a subroutine. So I'm going to build a subroutine here called raw, which is for raw round robin. And so we do this, and not all of the arguments make sense. Some things want to be applied, so I was just pushing things around here. So I'm going to split out the horizontal shuffle logic, and now we're going to okay, here's what I tried first. I was trying to say, you know, where it adds 10 to the teams that are in another pool, I'm trying to make it so I can take two pools and put them together. So that's why I had to split it out as a separate subroutine so that I could stream these two separate tournaments into one. First time I tried to make a range here, I said, well, start the range from 10 plus 1, so 11 for the second pool, and go up to the number of teams. But that's not right. And I realized, oh no, we can do that. The right way in Perl 6 is actually to go ahead and build the range object. And if you then add something to the range object, it automatically adds it to both ends of the range. So that just does the right thing. And you know, a bunch of this is changing defaults. And so we get to this thing, and at this point we can say, give me a pool of 8 and a pool of 7 put together. And now we'll take two tournaments and mix them up. But the other thing I really wanted to do was, and that this can't do, is often you will have a wider round robin than you actually have rooms. If you only have, you know, 6 people who are capable of quiz mastering, you can't run 1, 2, 3, 4, 5, 6, 7 rooms. So you have to be able to squeeze these things down. So I took a whack at this similarly. So I said, let's add a locations flag. It's an integer. Okay, so if there are locations, then there's some debugging there. What we're going to do is flatten out all of the things and then do what we call a rotor. So if you have an ordinary 17, yes, okay, so I didn't go far enough. Locations and flat, my flat. Is that where I wanted? Okay, if you have an ordinary 17 thing, works like that. And so if I now say locations equals 2, it does the wrong thing. So I keep going. And There we go. But that actually only works with the odd number ones, because the even numbers are generated by a different geometric algorithm, and it'll end up putting the same team in two different places at once. So you have to get a little fancier if they're odd numbers. So, and now we can pack 8 of them into 2 or 8 of them into 3. And there's other things that have been going on there, but that's probably enough of that. You still want to talk about RFCs, or you have more questions? Where was our RFCs? I'm always losing them. No, they were over here. Okay. What are the difference between the different releases of Perl 6, 6.A, 6.B, 6.C? We are currently on 6.C. Great question. One of the things that we decided in this whole RFC process was that we needed to separate out the idea of a language version from the implementation version. With Perl 5, Perl 5.26 is both the language version and the implementation version, because they are one and the same. With Perl 6, the official policy is anything that implements a test suite of a language can call itself that language. So 6.A, 6.B, 6.C are actually versions of our test suite that test what is Perl 6. There was this ancient joke that said, when is Perl 6 coming out? Well, Christmas. We just won't say which one. Until 2 years ago, when we said, well, it's going to be this Christmas. And so it sort of made sense. We also didn't want to have version numbers for our language that could be confused with implementation numbers. So Rakudo has an entirely different sort of a date-based, Rakudo, the implementation, our compiler has a date-based version numbers. And with the language version number, we didn't want it to change as often. Rakudo comes out every month, so it gets, every time we check in more, if you're ahead, then everything is a different version number. So that's changing constantly. The language wants to be more stable. So more in the vein of thinking more like, the different versions of C that the standards have had, or C++, or other languages that every few years come up with a new version of the language. And so we decided that we would use letters for the language versions instead. And when we did that, we didn't really want to, we really wanted to start at C for Christmas. So I sort of back-formed, the beta version was actually released on my birthday 3 months before Christmas. So that was 6.birthday. Everything before that was 6.advent, just because it was the advent of Perl 6. Just notionally. There was never a release, per se, of 6.A in that sense. But yeah, now we're on 6.D, 6.C. I'm still jet lagged. More coffee. So 6.C is that happens to be a Christian holiday, but we're going to be equal time. So 6.d is going to be Diwali, and 6.e will probably be Eid. Eid. F, I don't know. Fiesta, festival, whatever. Yeah. Well, maybe.
So following up on that, added.
Oh, yeah.
So is there a way to specify use 6.c, use 6.c
Plus stuff.
that includes that?
Yeah. Yeah. Is there a mechanism for using stuff that's, if you say use 6.c, you're asking for the 6.c language, and nothing beyond that. We nail down to the current versions so that we can do backward compatibility and know what version of Perl 6 they're intending to run under. But if you want to run under a newer version, well, in the case of Tweak, it's something that we just sort of added. You probably get at it from 6.c anyway. It wasn't. It was highly unlikely that anyone would already have a Tweak method. So I don't know whether this fell under this umbrella. But for things that truly are breaking changes for D, you can currently say use 6.d.preview, and we know some things will not be backward compatible. So if you want to move that new version, then you would use that.
Well, suppose you have various versions
Yeah.
and somebody wants to rely on that tweak, but wants it to automatically fail based on
If you have to, you can check the Rakudo version too for finer grain. But yeah.
use 6.c dot and test tweak
Yeah. Yeah. We might get finer grained with that. We haven't really needed it yet. It's one of those things that we'll have to be more and more rigorous as we go forward, and we're just sort of trying to plot out how do we make a language that we can change in the future and break a few things in a controlled fashion, deprecating things, and such that you can intermix code that says this is 6C code and this is 6D code, and they actually use nested settings so that the 6D hides 6C, which is a cute trick.
It would be nice to be able to
Yeah. Yeah.
that is without it being implementation. Without forcing the runtime for every single one of those. Well, you can still do the 6.c.
Yeah. To the extent.
If you need to support endpoint intermediates, you need to have available and maintain the version of the runtime library, the version of the setting for each one of those intermediate states as independent, addressable things. I'm just kind of saying, the one that has the tweak to say, hey, okay,
Well, we can take it to the IRC channel. Yeah, we haven't solved everything yet, but we've gotten to the place that we're very happy with things that we do have, by and large, and are just trying to make them faster and less buggy and more production ready all the time. Last question.
Where do I find a list of the principles and the expansions on those to give a little better idea of the philosophy building process?
I gave a talk on it a couple of years 3 years ago at YAPC. I don't remember exactly how long. I think there's a recording of it there, but I don't think I actually talked about. There's too many of them to actually talk about all of them. This particular file.
Instead of posting your slides, you could post that file.
I could post that file, yeah. Mind you, it will only do these fancy colors if you use the right Vim file. But yeah, there's not a lot of discussion of the actual principles except that this in this file. But that's these are all things that we've used over and over again over the course of the last 17 years now. Things that just keep popping up. You can't be both eager and lazy simultaneously. That really says you can't do time travel. And that's why we changed how the context works in Perl 6. It's no longer decides at compile time whether you're in scalar or list context, because it doesn't actually know that in Perl 6 until you actually bind the list to some signature somewhere. So that would require time travel. So that's one of the things that changed in order to get lazy processing, which allows us to talk about infinity and beyond. Well, maybe not beyond yet. We'll get there. Okay, thank you very much.